So here we're trying to find the area bounded by these graphs, which are fx e to the x and gx x squared minus 1. So that's our graph, that's g of x, and this is f of x. So when we're trying to find the area between two graphs, we basically have to integrate between the bounds. So here we want the area between x equals 0 and x equals 1. So that will be our bounds here, 0 to 1. And what we integrate is f of x, which is on top, and we take away the bottom graph, which is g of x. So let's sub that in. F of x is e to the x minus g of x is x squared minus 1. Okay, so let's integrate this. E of x integrated stays e of x minus x squared will become x to the power of 2 plus 1 over 3 minus x, and we have the plus c at the end. And we want to find this between 0 and 1. So let's sub in 1, so that's e to the power of 1 minus 1 to the power of 3 over 3 minus times minus is plus, so we're going plus 1 plus c. All of this take away. Now we can sub in 0, so that's e to the power of 0 minus x to the power of 0 over 3, well that's just 0. X is 0, so plus 0 again, and plus c. Okay, so that's going to be e to the power of 1 minus 1/3 plus 1 plus c minus anything to the power of 0 is just 1 minus times plus will make it minus, and plus will make it minus c. So let's simplify that. So that's e to the power of 1 minus 1/3 plus 1 minus 1. So this plus 1 and minus 1 will cancel, so we're just left with minus 1/3 plus c minus c goes away as well. So the answer we get is e minus 1/3, which is D. Okay, let's look at question 2. So with questions like these, it's good to think about, if you've got a denominator that's common to both of them, you can actually separate it out. So we can write this as integral of e to the x divided by e to the x plus 1 over e to the x. So we're integrating all of this, but we've just separated them out, d of x. So this becomes integral, well that's integral 1 plus, when you have anything in the denominator, we can bring it to the numerator by changing the sign in front of the power. So this is plus x, so we can write this as minus x, d of x. Okay, so let's integrate that. Integral of 1 is just x. Integral of e to the power of something is going to be e to the power of the same thing divided by its derivative. So the derivative of negative x is just negative 1. And our plus c. So let's simplify that. So this becomes x. When you divide something by negative 1, so that sign changes to negative 1. So negative e to the negative x plus c. So that's A for question 2. Any questions, guys? Okay, just moving on. Let's look at question 3. So here we're integrating a bracket. So what we can do is, so there's one way to do it where we let everything inside the bracket equal u. We can do this without assigning this, but this is just a nice simple method that we can use on any function that has brackets. So if you let u equal 4x plus 6, that means our du on dx, which means this derived, is going to be 4. So our dx is going to be du on 4. So it's just we have swapped these two over to get what dx equals. And so once we have done this, we can rewrite this question as 2 times the integral of u to the power of 3, and our dx now becomes, we can replace that with what we have just found, du on d4, or du on 4. So let's integrate that. So that's going to be 2 times u to the power of 4 divided by 4 times 1/4. That's that there. And if we simplify this, that's 2 times, now u was originally 4x plus 6. So we're doing that to the power of 4 over 4 times 4, which is 16. And if we keep simplifying this, that's going to be 1 over 8. So 4x plus 6 to the power of 4 divided by 8, or nr plus c. So that's d. Another way to do this, if you don't actually want to sub in u, is just go, so is 2 times 4x plus 6 to the power of 3. So what you do first is you integrate the bracket. So that's going to become 4x plus 6 to the power of 4 divided by 4, and times this by 1 over derivative of the bracket. So the derivative of 4x plus 6 is just 4. So that becomes 2 over 4 times 4 is 16 again, times 4x plus 6 to the power of 4, and the plus c, which also just becomes 1/8. So there are 2 ways you can do this. Okay, let's look at question 4. Pulse rates of adult men are approximately normally distributed with a mean of 70 and a standard deviation of 8. Which of the following choices correctly describes how to determine the proportion of men that have a pulse rate greater than 78? Okay, so to do this, there is 2 things we need to find: the value of z and whether we are looking to the right or left of the curve. Well, we can get the z value by doing our score, our x value, minus the mean divided by the standard deviation. So all that does is it rewrites the value in our normal distribution where the center is 0. So our x value is greater than 78. So our x is 78. And we want to know greater than. And our mean is 70 and our standard deviation is 8. So our z value is going to be 78 minus 70, which is our mean, divided by the standard deviation, which is 8. So that's 8 divided by 8, which is 1. So our z value is going to be, say, there somewhere. And we want to know the proportion of men that have pulse rate greater than 78. So this is the proportion of men that have value greater than 78, which is always to the right. So we want z equals 1, so that gets rid of this and this. And we want area to the right, so which is just B. Okay, question 5. The equation of the tangent of the curve is f of t equals te to the power of t at t equals 1 is. Okay, so if we draw that, we've basically got a function and it's te to the t. That's that function there. And at t equals 1, so this is our t equals 1, at that point, we've drawn a tangent to the curve. So we've drawn a line there like that. And we want to find the equation of this tangent. So because it's a straight line, we know that the equation is going to have the form y equals mx plus c. Well, in this case, we can say y equals mt plus c, just because this is our t-axis and this is our y-axis. Okay, so basically we need to find the value of m and we need to find the value of c to get this equation. So how can we do that? Well, we know that m is the gradient of that line, and we also know that we can get the gradient at t equals 1 by deriving this function and subbing in t equals 1. So let's do that. So we have to do y dash. In order to do that, we can use differentiation by parts, which is u dash v plus v dash u. And for this question, our u can be t. So u dash, which is its derivative, is going to be 1. And our v value is going to be e to the t. So just to recap, so if y equals u times v, then y dash is u dash v plus v dash u. Alright, so now we've got u, we've got u dash, we've got v, and so the v dash is going to be derivative of e to the t, which is still just e to the t. So we can write our derivative here now as u dash v, which is 1 times e to the t plus v dash, which is e to the t times u, which is t. So e to the t times t. Okay, so now if we want the gradient at t equals 1, that's what we're going to sub in. So y dash is 1 times e to the 1 plus e to the 1 times 1. That's going to be e to the 1 plus e to the 1, which is 2e. So we know that our m value is 2e. Okay, well, we can write the next version of this, which is y equals 2et plus c. Now we still need to find the c, and to do that we need to sub in values of y and t, so from one coordinate. So we already have this point. For example, when t equals 1, what does y equal? So we've got the equation that y equals te to the t. We're given that here. So we can sub that in. So y equals 1 times e to the power of 1, which is just e. So y equals e when t equals 1. So we can sub these values back in this equation now. So e equals 2e, t is 1. So that's just 2e times 1, which is just 2e, plus c. So c is going to be e minus 2e. So, okay, so we have our value of c now. So our equation is going to be y equals, so it's mx plus c, or in this case, mt plus c. That is, our m is 2e, t, and our c is e minus 2e, which is just 1e. So e minus 2e is minus e. That's just going to be minus e. And that is B. All right, let's look at question 6. If the probability of success in a Bernoulli trial is 0.3, the variance is. All right, so for a Bernoulli trial, the variance is given by doing p times 1 minus p, where p is the probability of success. So our p value is 0.3. So our variance is going to be 0.3 times 1 minus 0.3, which is 0.3 times 0.7, which is 0.21. So just a bit more about Bernoulli trials. So they are basically experiments where the outcome can only be either 0 or 1. And that's why it has this special equation that works for it. Normally we would get the variance by doing e of x minus e of x squared, where this is just the mean, and this is, so that's x1 times p1 plus x2 times p2, and so on. Whereas this would be given by x1 squared times p1 plus x2 squared times p2, and so on. And when you minus this from that, you would get your variance. But for Bernoulli, it simplifies down to just this, which is a lot easier to do. Okay, let's look at question 7. The life expectancy in years of an electronic component can be represented by the probability density function p of x equals 1 over x squared for x is greater than or equal to 1, or it's 0 otherwise. The probability that the component lasts between 1 and 10 years is. Alright, so for questions like these, let's just draw a function. Let's say that's p of x. So it's 0 before x equals 1, and at this point it becomes p of x. So let's say this is x equals 10. So the probability that the component lasts between 1 and 10 years will be given by this area under the graph, between 1 and 10. And the graph is p of x. So to get the probability, we have to integrate this function between 1 and 10 and just find that answer. So if we integrate from 1 to 10 for p of x dx, that becomes integral. Oh, by the way, this is the non-calculator exam, so that's why we're doing everything by hand. So 1 to 10, and for 1 over x squared. So we know from before that we can bring x squared to the top just by changing the sign to a negative. Okay, and let's integrate this now. So that's going to be x to the power of negative 2 plus 1 over negative 2 plus 1 plus c. And we want to integrate this between 10 and 1. Simplifying that, we get negative x to the power of negative 1 over negative 2 plus 1 is negative 1 as well. The plus c will cancel when we minus, so we can just get rid of it. And simplifying that, we have negative and negative. Oops, that don't know where we got this negative from. So x to the power of negative 2 plus 1 is just x to the power of negative 1 over negative 2 plus 1 is negative 1. Okay, so now we can bring that x to the power of negative 1 to the bottom by making it 1 over x to the power of just 1. And we're still dividing this by negative 1, and all that does is make our fraction negative. So we want to solve that for between 1 and 10. Okay, so let's do that. So that's going to be negative 1 over 10 minus negative 1 over 1, which is negative 1 over 10. Minus minus becomes plus. Now 1 over 1, we can write that as 10 over 10, which is just a fancier way of saying 1. And negative 1 plus 10 gives us 9 over 10. Now we can write this as a decimal. So 9 over 10 as a decimal is 0.9. So that's going to be C. All right, let's look at question 8. A test includes 6 multiple choice questions. Each question has 4 options. If the answers are guessed, the probability of getting at most 2 questions correct is represented by. Okay, so if you're getting at most 2 correct, that means you're either getting 0 correct or 1 correct or 2 correct. So we just need to find probabilities for those 3 scenarios and add them up. So for 0 correct, we would write that as 6, 0, because there are 6 questions, and so this is how many questions we have, and this is how many we want correct, which is 0. Now, what's the probability of getting a question correct? So if there are 4 options and there's only 1 correct answer, that's 1 over 4 probability that you'll get it right, which as a decimal is 0.25. And probability that you get it wrong is going to be 3/4, because there's 3 incorrect answers. So now we got to times it by probability of success, which is 0.25 to the power of 0. So 0 correct times 0.75 to the probability of, to the power of 6. So that's this here. For getting 1 correct, we would just change that probability to the power of 1 times 0.75 to the 5. And probability of getting 2 correct will be 0.25 to the power of 2 times 0.75 to the power of 6 minus 2, which is 4. And only B does that. All right, let's look at question 9. So one thing that will help us with this question is remembering that integral of f dash of x over f of x equals ln f of x. So whenever you get a question like this, it's good to see if the numerator is a derivative of the denominator. So here we've got y equals x squared plus 2x at the bottom. So let's derive it and see. So the derivative of that is 2x plus 2. And we can see that the numerator here is just half of this. So if I factorize this, it would become 2x plus 1. Which means if we integrated 2x plus 1 over x squared plus 2x, that would equal ln x squared plus 2x. Now the question we have is just half of this, because half of this equals x plus 1 over x squared plus 2x, because this 2 will cancel with that 2. And this is the question that we have here. So we can rewrite our question as half. So integral half of 2 times x plus 1 over x squared plus 2x, which equals ln x squared plus 2x, but half of it, plus c. And that is c. So one thing to keep in mind is when we integrate f, like y dash over y, the answer is always ln of y. So if you're getting options where there's ln in all of them, that's a good bet that you're supposed to use this formula. So then you just derive the denominator and you'll get an answer, which in this case is 2x plus 2. And just see how does this relate to the numerator that you actually have. So in this case, we know that this is just twice the numerator that we have. So we would just times it by half. All right, let's look at question 10. So 2 types of materials, A and B, are being tested for their ability to withstand different temperatures. A random selection of both materials was subjected to extreme temperature changes and then classified according to their condition after they were removed from the testing facility. The results are shown in the table. An approximate 95% confidence interval for the probability that material A will break completely or show defects is given by. Okay, so one thing to note that in these cases, our C is our population proportion, which is how many people have the defect that you're looking for divided by the complete population. Well, for A, 25 plus 35 of the material are broken, so which is 60, and the total number of materials there is 95. So our C value is going to be 60 over 95. And N is just the number, it's the sample size. So we've got 95 material A. So the option that meets this is A. Okay, so that's all the questions. If there are any questions on how to do any of these or any further clarification, please let me know. I am making a sample test with Work Solutions, so if you are interested in getting that, feel free to send through your email in the link below, and I will email it to you once I have that ready. All right, thanks for watching.